Almost every JEE aspirants and NEET aspirants think that projectile motion is all about memorizing 5 or 6 formulas of maximum height, range, time of flight, locus equation, and that's it. They are ready to solve numerical based on projectile motion. And that is where maximum students do the mistake. So what I'm going to teach you today in this video, that there is only one concept that you have to remember. And if you remember that one concept, you can solve the entire projectile motion concept on your own without memorizing the formulas. So let's go for it. So that single concept that I was talking to you is the concept of tunnel vision. Now what is tunnel vision? Suppose I'm driving a car. Suppose I'm driving the car in this direction, okay? So if I'm driving the car in this direction, I'm supposed to see only this direction. What happens to my left, to my right, I'm not supposed to see that. So that is called tunnel vision. Means these visions are now blocked for me. Only this vision, this direction is now what? Visible to me. So this concept, how to apply in physics? Think, there are 3 axes, x-axis, y-axis and z-axis, and they are taken by the concept of right hand thumb rule. So x to y, this is z-axis. Now when you see x, only see the variables and the parameters that exist here. Forget about y and z. Don't think about them. Same goes for when you see the y, forget about x and z. Only think the variables that are on the y-axis and apply the same concept for z-axis. And that's how you can solve complicated 3D motions. Now today's target is projectile motion, and projectile motion is 2D motion. So obviously z-axis does not exist. Ultimately 2D or 3D, whatever it is ultimately what? It is ultimately motion in 1D. So if your concept of motion in 1D is clear, then you can apply those concepts that you have learned in motion in 1D and apply for x-axis. Forget about the y. X-axis is 1D. Same thing, when you go for y, apply the motion in 1D concept to the y, and that's it. You will get the equations of y and x, and together they make what? 2D. So this is the idea. Project a particle. So project means throw. Projectile. A particle projected. That means a particle thrown. U at an angle theta. So the very first thing that you have to do whenever you see a vector inclined at a certain angle with respect to x or y, the very first thing is that you resolve the vector into components. So what is the x component? It is u cos theta. Now when you see and apply tunnel vision along x-axis, you see only u cos theta. Forget about any other variables. Don't see any other axis. That is the idea. What is the y component? It is u sin theta. What is the acceleration along y-axis? It is minus g, because whether the projectile goes up or down, the gravity always acts downward. Don't fall for that wrong concept where they tell you that when they are going up, it is retardation, and when the particle is coming down, it is acceleration. That means when you are going up, when this projectile is going up, g is acting in the downward direction, it is retardation because it is opposing the velocity, and when it is coming down, g is now actually supporting the motion and it is the acceleration, and that's why you should take it as plus. That is a bullshit theory. What you should do is that whether the projectile is projected up or down, it is all the time downward, and it's a vector quantity, and that's why the acceleration is minus g. Okay? So remember this concept. Now the next concept that you need is another very important concept, and we use it throughout, is that characteristic of time. Time along x-axis, time along y-axis equal to time along z-axis is equal to total time. So total time is time along x, time along y and time along z. They are all equal, and they are equal to the total time, because time does not depend on any coordinate axis. So now say this projectile goes in a certain path, and what is that path? That path is a parabola. So what is a parabola? Parabola is this curve. This is how a parabola looks like. It's a vertically downward parabola. So we'll now, without proving, we'll assume that this path is parabola, and we'll take a point, say capital A. Why capital A? Because it is the arbitrary point. And also remember that from wherever the motion starts, where the motion has started, at this point, this origin, so that point wherever the motion starts, should be taken as origin. So suppose if this is a tower, some building, somebody from the top of the tower has thrown the ball with velocity u at an angle theta. So what is the origin in this case? The top of the tower. In this case, the origin is the ground, and the projectile has gone from ground to ground. This is called full projectile. Okay. Now there are many different kind of projectiles possible. This is one of the projectiles. The top of the tower, it goes and falls. So this is a part projectile. Also, what you can do is that suppose this is the top of the tower and you have thrown the ball horizontally. So the projectile or the particle falls like this. This is the half projectile. There is another kind of projectile. Suppose this is an inclined plane. Inclination is say phi, and there is a projectile projected. So the particle goes in this path. This is called inclined projectile. So full projectile, part projectile, half projectile, inclined projectile. So these are the possible projectile motion. But all these motions come under this theory, because if your concept regarding this full projectile is clear, you just change the value of theta and slide minor tweaks and you will get into all these equations. Okay. So I'll erase this part and we'll right now focus on the full projectile. So what is the time taken by the projectile to reach point A? So let us assume that time is this small t, and this point has a coordinate x comma y. Coordinate is the displacement. So what is the displacement of this projectile along x-axis? It is the x coordinate. So what is the value of x? Now because there is no wind flow here, there is no friction regarding given by wind, so we'll assume that acceleration along x-axis is 0. But if suppose there is an acceleration along x-axis, then you can also take that value. Right now it is 0. So this means what is the characteristic of motion along x-axis? Because there is no acceleration, so the motion along x-axis is uniform velocity. Now you only focus on x-axis. That is called tunnel vision. That is the one concept you need. So what is the displacement along x-axis? It is x. What is the velocity along x-axis? It is u cos theta. What is the acceleration along x-axis? It is a 0. What is the time taken to move along x-axis? Is t. So what is the s, the displacement along x-axis? It is s equal to vt. So x is equal to how much? U cos theta into t. This is the x coordinate. Equation 1 formed. Now what is the y coordinate? Let's go for y coordinate. Now what is the displacement along y-axis? Displacement along y-axis is y. The coordinate is y. What is the time taken to move along y-axis? Ty is t. So, and what is the acceleration along y-axis? It is minus g, because g is acting downward. Now some of you may ask, sir, you have taken the equation only for ascending. What about descending? Remember, in case of descending, the mass will self-adjust. That means whether it is ascending, descending, or at maximum height, or it has gone below here, this equation x coordinate and the y coordinate that I am about to form will be valid. So let us go for the y coordinate. Tell me. You try to help. You try to say that answer in your mind. You see the tunnel vision. What is the initial velocity along y-axis? It is u sine theta. What is the time? T. What is the acceleration? Minus g. So which formula you will use? S equal to ut plus half at square. So this means the y coordinate is now y, which is the displacement, which is the s, is equal to u sine theta t minus half gt square. This is the equation 2 of projectile motion. Now see, x coordinate and y coordinate both are expressed in terms of a single variable called small t. So small t becomes what? It becomes a parameter. Now from energy conservation, because there is no friction here, so if this projectile is projected with velocity u, when it hits the ground, what will be its velocity? Its velocity will be along the tangent, and the value of that velocity v will also be equal to u, right? So from energy conservation, remember that whenever you throw a projectile from ground with velocity u, or wherever you throw a projectile with velocity u, when it comes to the same horizontal level, that means when it comes on the x-axis, it is about to hit the x-axis, it will hit with the same velocity u. But the direction of velocity anywhere on the trajectory or on the curved path is always along the tangent. So this means the projectile is all the time going along tangent. So here the velocity is v. And what is this v? V is the resultant of velocity along x-axis, which remains obviously unchanged. See the tunnel vision, which is u cos theta. And what will be the velocity along y-axis? Now you know the initial velocity along y-axis is u sin theta, acceleration is minus g, and the time taken to move along y-axis is how much? It is t. So what is the velocity along y-axis? That is going to be v is equal to u plus at, right? V is equal to u plus at. So what is the v along y-axis? Vy. What is the u? U is u sin theta. What is a? A is minus g into t. Plus minus, this will become minus. So the final formula will become u sin theta minus gt. This is the velocity along y-axis, and this is the velocity along x-axis. You can also do one thing, that this is a displacement along y-axis. If you take the derivative of this, also you will get to vy, and if this is the x coordinate, so this is a displacement along x-axis, you take the derivative of this and also will get to this formula. Now let's go for more formula. So this is the x-axis and y-axis. Projectile is projected with velocity u at an angle theta. The path is parabola. It has hit the ground with velocity v, which is equal to u. And from simple trigonometry, I can see that this angle is also theta, because if this is u cos theta, this is v cos phi, but v and u are equal, so u cos theta and v cos phi. So if you don't take this angle as theta, you want this angle to be phi, then v cos phi and u cos theta are equal, x-axis velocity. V and u cancels out because the value of u and v are equal. So cos theta equal to cos phi, so this theta and this theta will be equal. Remember this. So what is the velocity at this point? So suppose this is O, this is the arbitrary point A, and this is say maximum height B, and this point I will take it as C. Okay, so what is the velocity along y-axis at the point C? It is going to be Vy, the mod value is u sin theta, right? But what is the direction? The direction is negative y-axis, so this is minus u sin theta. Now you use the tunnel vision along y-axis and use the formula v is equal to u plus at. So what is your final velocity? You reach from O to C. What is the final velocity at C? It is minus u sin theta. So instead of v, put minus u sin theta. What is the initial velocity along y-axis? So this is u, this angle is theta. So the initial velocity along y-axis is u sin theta. So this becomes u sin theta. What is the acceleration along y-axis? This a, this is plus minus g. Why I took minus g? Because the gravity is acting downward, right? Because the gravity is acting downward, that's why I've taken minus g. And what is the time taken by this projectile to reach from O to C? This is called time of flight, capital T. So the entire concept is based on the tunnel vision, the singular concept. And if you know this, you can derive the problem on your own. So suppose if somebody erases all the formula from your head and you try to solve this a problem from projectile motion, you seriously don't need to remember the formulas. You can do it on your own, right? So what is the what is the time of flight formula? So if you take the side change, that minus gt becomes plus gt. This goes on the right hand side, this becomes 2u sin theta. So what is the time of flight? The time of flight is coming as 2u sin theta by g. So this is the total time of motion. But what is the property of time of motion? This is the time of motion also along x-axis. This is the time of motion also along y-axis, and this is total time, and it is equal to 2u sin theta by g. So if this is the total time of flight, now only see the tunnel vision. Only use the tunnel vision. Now only use the tunnel vision along x-axis. What is the velocity along x-axis? It is u cos theta. What is the total time of motion? 2u sin theta by g. What is the coordinate of point C? This is usually taken as r, 0, because this is called range. So range is what? The maximum x distance covered. The maximum distance covered along x-axis. In case of full projectile, it is r, 0. But suppose if it is thrown from, say, here a tower, you have thrown, so this projectile will go and fall here. So this bottom line this line is going to be what? Will be your range. So in this case, this is a part projectile. In this full projectile, this OC is your range. So what will be the value of OC? Let us try to calculate that. So x-axis velocity is u cos theta, time taken, x-axis 2u sin theta by g. So the range r is equal to how much? So r is equal to velocity along x-axis is u cos theta into capital T. That means u cos theta into 2u sin theta by g. So what I am getting the formula as, take 2, u cos theta is the initial velocity along x-axis, u sin theta is the initial velocity along y-axis divided by g. This is the range. And also time of flight is 2uy by g, right? U sin theta is uy by g. Please check. Now let us try to find out the maximum height. Now for maximum height, at the highest point, what is the velocity along y-axis? What do you think at the point B? What should be the velocity along y-axis? It must be 0, because if it is not 0, this projectile will further go up. Only see the tunnel vision along y-axis, right? So Vy must be 0. Now I need this value, capital H. So B point will have some x coordinate and y coordinate is capital H, right? X comma H is the coordinate of point B, and this is necessary. So this is the displacement along which axis? This is which coordinate? X or y? This is a y coordinate. That means this H is the displacement along y axis. So this means this is S y. S is displacement, S y is capital H for maximum height. Now I know the final velocity along y axis at maximum height point B. I know the initial velocity, which is u sin theta, and I also know the displacement along y axis. So what I can do is that I can use this formula, v square equal to u square plus 2as, the kinematics formula. What is my v? It is 0 square. What is my u along y axis? Tunnel vision along y axis, u sin theta whole square plus 2. And what is the acceleration along y axis? A. It is minus g, because gravity is acting downward. And what is the maximum height? It is capital H. Do the side change, simple calculation, you are getting the formula u square sin square theta divided by 2g. Also you can write this as uy square divided by 2g. So this is maximum height. So we got the range, we got the time of flight, we got the h. Now let us try to find out the locus equation. So to find locus equation, I'll erase this. To find a locus equation, we'll take an arbitrary point A. What was the x coordinate? As we have discussed earlier, using tunnel vision, u cos theta t, because motion along x-axis is uniform motion. What is the displacement along y-axis? It is u sin theta t minus half gt square. So from equation 1, what is my t? T is time, t is time. So see, two different variables, x and y, are expressed by a single variable, and this single variable is called time. Suppose in case of ellipse equation, what your x is how much? A cos theta. Y is how much? B sin theta. This is for ellipse. So now x and y are two different variables expressed in terms of a single variable theta. So this theta is the parameter for ellipse. The concept of finding the locus equation is that you eliminate the parameter. So same goes for projectile motion. To find the equation of this locus, the parabola, what we will do is that we will eliminate this time t. So whenever you expressed two or more than two variables in terms of a single variable, that single variable is called parameter. And to find out the locus equation, the concept is that eliminate the parameter. So to find the locus equation of this projectile motion, what you are supposed to do? Eliminate time. How to eliminate time? Find the time from equation 1. What is t? It will be x by u cos theta, and put the value of x by u cos theta in the equation 2. So what is the y coordinate coming? It is coming as, first t find, t is x by u cos theta. Okay, now put this value of time in the equation 2, and what I am getting? Y equal to u sin theta into x by u cos theta minus this minus half g into this square. So x square by u square cos square theta. Cancel the u, sin theta by cos theta becomes tan theta. So what is the locus equation? It is coming as y equal to x tan theta minus gx square divided by 2u square cos square theta. This is the locus equation of the projectile motion. Okay. Now this can also be slightly modified. Let us do that. So how to modify it? Take x tan theta out. So if you take x tan theta from this equation common, you get y coordinate y as x tan theta is outside. It is coming as 1 minus g x square, that x is out. So x divided by 2u square cos square theta, and this tan theta is out. So this means tan theta will go at the denominator. I'll just erase this diagram. So tan theta goes here, right? So now tan theta into cos square theta. This is sin theta by cos theta. It cancels out. So what I'm getting? I'm getting x tan theta into 1 minus, keep this x here and take the g at the denominator. So this comes as u square 2 sin theta cos theta whole divided by g, right? But this is what? If you remember, this is your range. This is the range that we just calculated. So this means the locus equation has now become y equal to x tan theta into 1 minus x by r. So see, every formula that we are deriving for projectile motion, and as we will derive in case of 3D motion in future, you will see that every time I'll be using the singular concept of tunnel vision. So if you do remember the concept of tunnel vision, it is very helpful. It will help you in solving problem, and also if you forget some formula, you can derive on your own. You don't have to depend on your memory. So that is very, powerful. So in that note, I'll say bye-bye for today. For the next video, we'll go more into this theory and some very interesting projectile motion problems, and I'll solve one very interesting problem. So please do subscribe. Tata for now. Bye-bye.